Let's build a truncated tetrahedron. We're actually going to build three different truncated shapes. They're all Archimedean solids. There's another video you can watch on Platonic and Archimedean solids. What makes it so nice is that you have this hexagonal shape that you can get from just 6 tiles and 9 connectors. It's almost a perfect hexagon. What makes it not quite so perfect, you maybe see, is that it goes up and down out of the plane. And that's reminiscent of what 6-carbon ring cyclohexane does. If you're familiar with organic chemistry, it kind of puckers up and down out of the plane. But that is not enough to make a difference. For this purpose, we can treat that as though it's a completely flat hexagon. And you'll notice something. Of our 5 Platonic solids, 3 of them are based on triangles, the tetrahedron, the octahedron, and the dodecahedron. Truncated simply means you cut off each corner. But when you cut off the corners of these, the faces that are triangular turn into hexagons. Hexagons like this. So it turns out from just this shape, we can build each of these truncated versions. Okay? This one requires 4 hexagons. That's pretty easy. This is going to require 4 plus another 4, 8 hexagons. And this is going to require 20 hexagons. But we're just going to start with the truncated tetrahedron right now. Okay? So here's the shape, and I'll show you how to make that. It's pretty straightforward. We'll make it out of green. You want to put them together with a zigzag connection. And then, to confirm that it's zigzag, go like that, make it into a kind of a beak or a thorn. It looks like either one of those. Okay? That's 1/3 of the hexagon. Again, takes 2 more. This right here would not be a zigzag connection, it would be spiral. And if I go to fold it, it'll be obvious. Yeah, that's not going to make a beak. So we turn it 90 degrees, and now we got a beak. And by the way, it doesn't matter which way I go, that way or that way. So this is very easy construction. You don't have to pay much attention. If you're not making a beak, switch it so you are making a beak, and they're going to go together like that. Let me get the 3rd one here. Boom. I'm not even going to look at it, how I put it on there. Oh, good. And there we have it. And some of our shapes have kind of a clockwise one or a counterclockwise, a left-handed, right-handed. Not this one. Straightforward. And now we'll connect these very straightforward. So, don't connect them like this. There are other shapes we can build that do that. We're going to connect these like they're big old sections of a pie. A third of a pie, a third of a pie, and here's the remaining third. And whoops, let's put those on the middle shapes there, and the middle of the edge. And there you have it. Now, if I go like this, it's a very puckered hexagon, but I'm going to flex that like that, and now it's almost nearly flat. Okay? So, there's 1, 2. I've already got a yellow one made, and how about an orange one? Okay? Again, we're making this, so we have the 4 hexagons, 1, 2, and the other 2 are on the back side. You can't see them. Where are these triangles coming from? Those triangles are going to come from the space between the hexagons, so like here, okay? As we connect 3 of them. Now, you notice something. I was putting them with the spikes pointing inward. You can do that. Or you could have them with the spikes pointing outward. Okay? Both of those I would consider truncated tetrahedrons. We'll make both of them. If I want to do it so that the spikes are pointing outward, it doesn't really matter how I connect these. Okay? That is, I can connect them one to another, and that right there, you may or may not notice it, is a zigzag connection. That right there. That'll work if I want to have the spikes pointing outward, but if I want to have the spikes pointing inward, they're going to get in each other's way. So instead, and we'll do this for all these, if you want to do it so you can invert it, let's have it be a spiral connection, because now, look at how much more that can fold. The spikes, the little thorns miss each other. Okay, so that's important, a spiral connection there. Okay, we skip this one because it's going to be part of the triangle, and now we're going to put another spiral connection here. Is that spiral? Nope. So I'm going to turn it I'm going to turn it like 990. This would be just turning it 60 degrees. There. Okay, and look at how that folds. And that makes it so we're going to have a connection right here between these two. There we go. That is this top little triangle here, and these are my 3 hexagons. Now we're going to put this one on the other end, and if I put it the wrong place, those spikes, those thorns are going to get in the way, but right like that, and we're good to go. Now I told you that the it wasn't quite flat, the hexagon, and you're going to see that these angles aren't exactly perfect, but the connectors are forgiving enough that that's quite all right. Whoop. So connect there. See how it doesn't quite line up like it should, but again, there's enough flexibility. Some of the other shapes, the truncated cube for instance, it's much more aligned. But this one being small, I guess it exaggerates how far off those are, but it still gives you this shape as a truncated tetrahedron. There you can see that triangle on top, hexagon, 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 and here are the 3 other triangles. Okay, so that is the, we'll call this not the spiky, but the inverted spiky truncated tetrahedron. If I open up a few of these, and let's see, I think I'll have to break almost all of them there to invert it. You know what? I think in the inverted shape, the alignments are much better. Yeah, look at that. That's lined up just right. So, in the spiky version, I mean. So there's our spiky truncated tetrahedron, and the other we'll call the inverted spiky truncated tetrahedron. Okay?